Yeah, so this is the ski slope problem. Yeah. So yeah. Um, yeah, so basically there's n locations. You can think of them as some kind of a tree, um, a rooted tree, right? Right. Yeah, and when you start at a node, yeah, yeah. So this has like some difficulty DI and some enjoyment EI. Yeah. And then yeah. So then the total number of happiness is going to be like the sum of EIs. Um, yeah. Sum equals happiness, right? Yeah. So there's a bunch of people who want to ski and you want to maximize their happiness. And for each person, they have some skill level and some courage level. And they're allowed to go to a node if, let's say that like the skill level is S, skill S, and let's say they start here. I'll just make this a little bit bigger. Yeah, change the color. Yeah, um, yeah. Let's just say there's a bunch of nodes. Skill S, courage C. So they're allowed to go to a node if um, number of elements that are strictly larger than S are at most C, right? Yeah. So basically on the path from here to the root, there shouldn't be too many elements that are greater than S, right? Um, yeah, yeah. Uh, yeah, so there are like some subtasks. Yeah. Uh, but yeah. Uh, I guess an observation, something to notice is that the courage level is going to be at most 10, right? Yeah. So we can try thinking about this process like backwards, right? So where they start from the root and then they want to go to the some point in the tree, right? So they start at the root. So if we visualize the process backwards, they start here at the root and then they want to go to some part of the tree, right? Right. Um, and if this person has skill level S and courage C, then they can either go down if yeah, if this thing is like less than S, or if they haven't used up all their courage, right? Greater than S, sorry, less than or equal to S or greater than S, haven't used up courage. Right? So one way you can think of this problem is when they're going to a location, you can maintain a state, right? So the state you want to maintain is like uh courage um used up and then the node, right? So we can consider the states being like this. Since the courages are at most 10, there's going to be up to 10 in the states. So yeah, so you kind of have some kind of state space where you're going from the root, and then at each step, you can either choose to go to a child without that has strength less than or equal, or difficulty less than or equal to your strength, or you can use your courage and go to any node, right? Yeah, yeah. So that's like the high level idea. Yeah. So the states are like courage used up and node, right? So one way you can try to visualize this is there's like one tree. Uh, so we used up 0 courage. Uh, and then there's another tree where we used up 1 courage. Basically, when we're using up courage, we go to the node on the next tree. And then there's another tree where C is equal to 2. And you have like 10 of these trees. Yeah, so this is like one way you can try visualizing the state space. You start over here. You start over here, and then you either go to a child that has small enough difficulty, or you use up courage and then go to a new child, right? Yeah. Um, and then let's say your strength is S. Then within the courage equals 0, uh, using up courage equal to 0. Basically, the states you can reach are all paths that you can take, where all of these edges are less than or equal to S. And then you can reach more things in the C equals 1 because you can take any edge and then go to the next state. So maybe like C equals 1, you can reach like these nodes. And then C equals 2, you can reach like more something, right? Yeah, so this is like what the reachable states will look like, right? Yeah. Yeah. So if you fix the strength S, you're gonna reach like these things, right? And then as you increase S, you're gonna be able to reach more and more states, right? So let's say that yeah, so S2 is greater than S. So for S2, you can reach these states. Um, and then for S2, you can reach these states, and you can reach more states when your strength is equal to S2, right? So this suggests iterating over the cows in increasing order of strength, and then trying to maintain like what states you can reach, right? So we can sweep over cows in increasing order of S, and then try to maintain like what states we can see, right? Um, so we're gonna do some kind of search, right? Uh, yeah. So like how you can maintain these kinds of things when you're actually implementing it can have like some 2D array that tells you whether you visited a node and used up a certain amount of courage, and then you can also um, have like um, f of c, which is like the max happiness you can get uh, using C courage, right? Yeah. So when you're implementing this, like it's going to look something like this. And then when you're sweeping them in order of S and C, um, the answer for SC is going to be max of F0, F1, all the way up to FC, right? Remember, F of I is the max happiness we can get if we use I amount of our courage units, right? Yeah. Any questions? I'm gonna go over the implementation of how you actually do this search, but like the high level idea is, yeah, you want to sweep over the cows in increasing order of strength, and as the strength increases, you're able to visit more states, um, and the maximum happiness is going to increase. Yeah, and as the strength increase, the states you visit will be like a strict subset of what you're able to visit earlier, right? Yeah. Yeah, just as a reminder, like what the transitions actually look like. So if your strength is equal to S, so this is a node, and these are its children. Let's say the state is equal to SC, right? So some of these will be less than or equal to S. Some of these will be greater than S. So you can either choose a child that's less than or equal to S and then transition to the state. So this is U, this is V. You can transition to the, yeah, sorry. Uh, state is like the node and then C. You can transition to um, VS, or you can pick any node, and then you can transition from UC. Right. So yeah, either you don't use up your courage, transition to VC, or you can use up courage and then transition to VI C+1. Right. So these are what the transitions are going to look like. Either go to some child that you're strong enough to ski, or to go past, or you use up courage and then you go to any child. Yeah, so this is what the transitions are going to look like. Actual implementation. So remember we sweep over S. So we're like iterating over SC. So for SC in the sweep, in the ordering. Yeah. So we want to like consider what are the next places to that we can visit. So how we can do this is we can store a priority queue uh, where the elements are of the form strength, node, and then how much courage we used up, right? Um, so basically, yeah. So the priority queue is going to tell us like this is the node that we want to visit. Uh, sorry, not strength. This is like difficulty. Yeah. So elements of the priority queue will be telling us we haven't visited this node yet. There's some difficulty to get to this node, and it's going to be at some state C, right? Yeah. So once we have this priority queue, then yeah, we can just do this while uh, PQ not empty. Then we can consider the top element. It'll be some kind of difficulty, and then yeah, and then some node, and then some courage in the state. And since the priority queue is ordered from smallest to largest, then we just break whenever this difficulty is greater than S. So break if the difficulty is strictly larger than S. And then otherwise you explore more nodes. Yeah, so that's the idea of how you implement this. Yeah. Yeah, so that's the solution. Yeah, so I'll just summarize what how we did this. Yeah. Yeah, so the idea is that as as the strength increases, yeah, so we can maintain these states where it's like one part of the state is how much courage we used, and then the other part of the state is the node. Um, yeah, and then uh, yeah, and then as the strength increases, we're able to visit more states, right? Um, yeah, and so this suggests sweeping over the cows in increasing order of strength and then considering which nodes we can visit. Um, yeah, and then yeah, so we can do this with some kind of search with a priority queue where the things are ordered in terms of the difficulty to get to it. Yeah, um, and then we can compute useful values that are useful um, to be able to yeah, answer our queries, right? Yeah, yeah, so that's the solution. Yeah, any questions? Yeah, so I guess a comment about this problem. Yeah, so this problem is probably quite, yeah, I'd say it is quite uh long to implement. There's some detail, like you have to think carefully about details. So implementation wise, yeah, this is probably the most implementation heavy problem, but yeah, um, it's also maybe in some sense like if you do a lot of problems, um, this this is like yeah, like I've done a lot of problems. So I think this was like the easiest one to come up with a solution to, just because it's like similar to other kinds of problems. Uh, but yeah, it does take it is tricky to implement. Great. Any questions? I'll hang around for a couple of minutes. Feel free to ask anything. Yeah, I'll also go over like the slide summary. But yeah, I'll also be around for a few minutes if you have any questions. Uh, yeah. Uh, okay. I think my screen share is working. Okay. Yeah. Yeah. So yeah. So yeah, there's a summer camp this July to August. Yeah. Uh, yeah. And then XCamp has mock test class. Yeah, uh, yeah. And then just a summary of like what the problems required topic wise. In my opinion, I think I'd say this was harder than the average silver contest. Yeah, so the first problem was kind of a math problem. It's a constructive problem. Yeah, you need to construct a solution. And, um, yeah, and then the second problem is a greedy problem. Yeah, and then the third problem, yeah, um, as we mentioned earlier, yeah, it would probably fall under sweep and search. Also, there's some amount of DP to compute, like the happiness at each node. Yeah, yeah. So yeah, I'll be around for a couple of minutes if you have any questions about anything. Uh, yeah, anything about XCamp or anything about the problems. You can also feel free to type in the chat. Yeah. Um, what will the cutoff be? Uh, um, it's hard to tell. Yeah. I mean, I don't know the answer from my end, so I can't. I mean, I can't say anything for certain. But yeah, I'd be surprised if it's above 750. But yeah, I guess the last few contests they've had a trend of being around 700. Um, and in my opinion, this one felt harder than the other ones. Okay, thanks.